Here is the demonstration of our microprocessor assignment with the LPC2103 development board. Our task here is to get the LED on the board to blink when the push button on the board is pressed and released, and to stop blinking when the same button is pressed and released for another time. The hardware items needed are the LPC2103 development board. This LPC2103 development board can be purchased at the SparkFun Electronics website at www.sparkfun.com. Also, we need a 9-volt power adapter, and depending on the combination of hardware and software that you will be using, you might need some extra items as well. And for our case here, we need the RS2320 cable, of course a computer with 0 port. Well, let's proceed to the software installation and configuration part. And the software requirement is pretty simple for this assignment. The Winamp compiler and the Felix Flash utility. Of course, you can use other compiler as well. You can get the Winamp compiler for free from the internet. And here's the website. And this is the URL here. And as you can see here, there is a link for you to download the package. After you have it downloaded to your computer, you can extract the package to your computer. And then there are some environment variables for you to set. Well, let's go through them together. You need to go to Control Panel, System. Advanced tab, click on this environment variables, then search for the path. Edit. Then you will need to append the path to the directory that you have just extracted the Winamp package to the end of this line here. Okay. Now you can go to the Winamp directory, PM directory, and double click on this PN executable file here to bring up your programmer notepad. Have my project ready here, but create a new one if you don't already have one. For this assignment here, these are the files that are needed. The RAM and ROM declaration files for the board that you are using, and then here is the header file. It is also subject to the board that you are using, and this is the startup file. All these files here you can easily get them from the internet, and we need a make file here for compilation, and this file can be customized from the existing example that comes with the package. And of course we need to have our C program here. Let's take a look at the C program that I have here. It's a very simple program. Here's the preprocessor directive to include the board header file, and then declaration of the items that will be used on the board. For our assignment here, we would only be using the push button and the LED, which are connected to pin 15 and 26 respectively, and then we declare a variable here to keep track of the LED state, and then we have definition of the sub-functions. The first one here is to initialize the LED, and this is to turn on the LED and to turn off the LED, or this one is to introduce some delay, whereas this one here is to blink the LED. As can be seen here, this is very simple function. This is the shift. Okay, now this is our main function. It will keep checking for the push button whether it has been pressed, and then it will wait until it is released. It will flash the LED until the button is pressed and released again, then it will turn off the LED. Well, very simple. Then we save the changes and compile the program. You can check the status of the compilation from this window here. Then we need to verify that the compilation has been completed with no error. Then we are all set to go. Next, we'll move on to the hardware configuration. First, we'll connect the serial cable from the computer to the board. Then we'll plug in the power supply. In order to program the flash, you need to connect a jumper to the BSL pin on the board. After this is done, we are ready to program the flash. Okay, let's bring up the flash utility. Next, we need to load the hex file that we have just compiled. Here, click on this red device ID button to communicate with the board. We need to press the reset button on the board and press OK. See, read part ID successfully. Now we have a connection between the board and this flash utility. We can then load the program to the flash by pressing this upload to flash button here. Okay, this is done and file upload successfully completed. Now the board has been programmed. Let's check out whether it is working correctly. We will need to first pull out the jumper that we connected when we programmed the flash, then press the reset button. Now the program is running and it will detect when the push button is pressed. It will blink the LED and it will stop blinking for the subsequent press. Well, it seems to work. I guess that concludes our presentation today, and thank you for your time, and I hope you had fun.